Nuclear power, 4.2.4. Here we're going to be talking about nuclear energy, which is made from uranium, which is also a non-renewable stock, meaning that in some distant future we could run out of it or explore more reserves that are available through different processes. Some of the facts about nuclear energy: the units are gigawatts, which is a very large number, and units of power are megawatt hours. You think of a light bulb, the units of power are kilowatt hours. So we're talking about a very big scale of energy generation. Percentage efficiency, still doing the research on that. Profits high, but very regulated. This is a heavily regulated industry. Externalities are very high because storage of spent radioactive fuel rods is really not figured out yet as a safe way to do that. And reserves are available by improving the technologies that we use to make nuclear energy, either through the development of breeder reactors or through nuclear fusion, which is a much cleaner version of that. And nuclear energy is energy in the nucleus core of an atom and can be used to make electricity. The energy must be released through nuclear fusion or fission. Atoms are split apart to form smaller atoms, releasing energy. Nuclear power plants use this energy to produce electricity. Pretty simple? Maybe. Maybe not. Let's take a look. Just talking a little bit more about reserves and some of the efforts underway. There is a lot of spent nuclear fuel that still has potential to create energy, and so Bill Gates and others who are essentially venture capitalists they're investing in new technologies to try to harvest energy from that, which would create a really good opportunity to create energy from waste. Just from the experience point of view, the amount of nuclear energy that's created, the amount of electricity generated, is really tremendous and has brought comfort and convenience once again to millions and millions of people all around the world. Not everyone, but we're finding it to be something that is highly beneficial to society. Some of the sensory impacts, when you look at the nuclear silos there, or the structures there, if you didn't know that there was a high-risk energy system in there, you might not think of those as ugly. And of course, this is a picture with sunflowers in the foreground to make it look nicer. Nuclear in some countries like like France, 75% of the country's electricity is coming from nuclear. So this is a pretty well thought out, highly valued form of energy, and many consider it a transitional energy source to renewables, meaning that it's far cleaner than fossil fuels, but also providing a lot of energy. A little bit more on the systems of how this works. Nuclear reactors contain and control chain reactions while releasing heat at a controlled rate. Sounds good. A nuclear power plant uses that heat supplied by a nuclear reactor to turn water into steam, which spins a turbine that generates electricity. So even like hydro, we're always spinning turbines to try to make electricity. Just looking at some of the systems through the lenses. So this is a highly centralized, high infrastructure system that has to be created, and these systems cost about $10 billion on many cases in 10 years to build. Lots of ecosystem risks. A nuclear meltdown would create quite a dead zone, and we see that in Fukushima in Japan right now, where we have 300,000 people can never go back to their homes in their lifetimes. And on the other hand, though, the system of nuclear energy, once it's running and once it's rolling, is pretty efficient and pretty reliable, I guess is the case there. But with a huge amount of regulation for safety. Quick look at the systems and how they work. Number one, uranium mining is conducted and brought to a conversion place to make it into a gas. Number three, some of the depleted energy goes off the system. Eventually it's made into fuel fabrication, or rods as we call them. Number five, electricity is generated. So that's the part that we care about. But then there's a whole additional phase where we have to go into waste disposal units. And as you can see in this drawing here, number 9, we've got spent fuel rods way under the ground. So there's a lot of controversy and a lot of worry about how this nuclear waste is stored. Not a closed loop system. Looking at culture and society, which is probably one of the biggest objections to nuclear. First off, this is a information age technology, meaning that it's an older kind of energy. Societal benefits are very high, extremely high, but the societal costs, as we're going to see here on the right, can also be very high. So nuclear power plants do deliver consistent electricity to millions, but after accidents at 3 Mile Island, Chernobyl, and Fukushima, this reminds us that nuclear power can and is actually very dangerous. And many in the world connect nuclear power or energy to nuclear war and nuclear weapons, and the line between those is very thin, and so you'll see that some countries will try to block other countries from becoming a nuclear power, because when you're creating nuclear energy, you're also creating the ability to create nuclear weapons, which makes larger societies very uncomfortable. And then, of course, we have the disposal problems, which I spoke about. So if we had to say whether nuclear energy was sustainable or unsustainable, we'd probably say unsustainable because of the open loop and the disposal problems. However, we do see it as a great transitional source. Some of the events that happened recently that have shaped public perception was the Fukushima Daiichi nuclear disaster, and these are just some pictures of that. In Japan, people lost trust in the government, lost trust in their food supply that may have come from that region, lost trust in the corporations that were in charge of the nuclear plants. Really just a failure on many, many levels. Yes, the tsunami hit it. Who could have predicted that? 300,000 people were evacuated from their homes and will never return to those homes because the area around the nuclear site is now a dead zone. In Germany, after the Fukushima disaster, protests started to force Angela Merkel to consider ending the nuclear program in Germany for good. And in fact, she did come forward, and they have ended their nuclear program, meaning that they will use their nuclear plants they have until they are defunct. And they'll, at that time, should be rolling pretty well in renewable energy, which they're already one of the world's leaders in. In the U.S., this is the Yucca Mountain, considered to be a potential site for nuclear waste storage way under the mountain. There's a lot of controversy in this country about this. We see protests all the time. There is, however, another group of people who want this to happen because it'll create jobs. And that's always the dilemma about the ethical foundations of these and what makes the most sense. And so in any case, the radioactive materials will be dangerous for about 500,000 years. So it's hard to even manage. How would you even do a graphic design sign or even a language that you could know that would be around in 500,000 years? So for example, English, you could make a sign in English, but the chances of English being a commonly used language or even known at that point is unknown. Pretty interesting dilemma. So in summation, looking at nuclear energy, I'm just going to run all these up. So nuclear power brings comfort to millions, and the sites really aren't really that unattractive. However, when you begin to realize some of the cultural aspects, it looks a little bit scary. From a fact, it's considered a transitional energy source to renewables, financially lucrative. The system itself cannot start up and stop down very quickly, so pairing it with renewable energy, which I'll talk about in the next lecture, is not very likely. In terms of quality of life, technological advancement, it's huge, but the societal costs, deaths from accidents, threats of mass deaths due to meltdown and connection to nuclear war all make it a questionable energy choice, and probably not the ideal choice if you had to pick one, but certainly something of high value. And finally, the fact that it has an open loop system where the disposal has not been connected and figured out makes the question of whether nuclear energy is sustainable or not, and thinking about future generations. Certainly for now, it does a great job of giving us energy now today, but in 100 years or 200 years, what kind of legacy will nuclear leave to future generations? So again, back to the same conclusions we've had throughout the fossil fuel and non-renewable stock lecture, is that if we can find ways to design buildings and cars and live in a more sustainable way, we will reduce the need to use these kind of technologies significantly and also make renewable energy more powerful. Thank you.